thing.
Okay.
And you don't have to go into the deepest spot.
Last week, we looked at a couple of stream morphology types that are typical of high gradient streams, the plain bed form and the steppe pool form. This week, we want to expand on that basic introduction and learn a method that stream ecologists use to determine the slope of a stream channel, and following from that, how we collect the data that can be used to create an accurate profile map of the stream bed itself. We'll use that profile map to locate and quantify pool habitat for trout. We'll then work on evaluating the quality of that pool habitat in terms of its frequency, the relative size of each pool, and most importantly, their residual depth. The first tool, the one you can see the stationary worker standing on the inside of the bend using, is called a surveyor's level. The optical level is basically a low-powered telescopic sight with crosshairs that will be used to take a reading from the next tool. The next tool is the level staff. Essentially, it's a fancy ruler with a cryptic set of markings on it that is used to mark specific locations whose elevations you are working to measure. We'll spend time working through a practice data set to get a better sense of how the field observations that are made using these tools and method are translated into stream profile maps. But let's look quickly at what's going on in this video and think about how the profile data is being generated. The key to the whole process is getting a baseline measurement that allows you to establish the elevation of the eyepiece of the surveyor's level itself. Seen in the diagram is the horizontal line of sight. This baseline measurement is always the first observation taken and is usually called the back sight. The back sight measurement is ideally taken against a benchmark with a known absolute elevation above sea level, although for our purposes we can establish it using an arbitrary value against which accurate relative elevations can be calculated. The height you see represented here would be 3.625 feet. Since we aren't getting the opportunity to do this in the field, you don't need to worry about exactly how this value is being read from the level staff. The take-home point here is that with these relatively simple tools, very precise measurements can be taken. In this case, down to the thousandths of a foot. Once you have the baseline, or the horizontal instrument height established, you can move on to taking measurements of other downstream elevations. Typically, field workers will look to take readings at the head or the beginning of a pool, locations along the pool to find its deepest point, and another measurement at the tail out or the pour point where the water exits the pool and the stream is at its shallowest. The worker with the level staff will continue downstream while the worker with the level remains in place, pivoting the instrument around the point of known elevation to make and record height observations from the staff using the telescopic sight. Time to look at some data.